Right. Let's dive in. We're in 1.6. Continuing our 1.8. So one more hour, we're on good track. So, and good into chapter 2 a little bit. So, now we're dividing. So we've added, subtracted, multiplied. Now we're dividing. What's the rule for dividing? I mean, you know how to divide, but what about signs? Is this one going to come out positive or negative in the end? Negative. It's the same rule as for multiplying, huh? If you have two negatives divided or multiplied, same rule, that would be positive. But one negative when you're dividing or multiplying just comes out negative, doesn't it? It's the same exact rules. Dividing and multiplying always have the same rules. You'll see that all the way through the course. Whatever's true for dividing is true for multiplying. They hang together, those two rules there. 8 divided by 4? 2, so it's negative 2. Good? I'm going to move on if you've got that. So negative and positive. So two negatives make a positive for multiplying and for dividing. Same rules. But, kind of like what I'm doing now. I did last spring. So, so I don't know. I just hit about half of them, probably. Yeah. But you can also, I'm also saying you go by and slow this down, too. If I'm going too fast, you can just pause it and back it up and all that kind of stuff. But yeah, I try to get to the harder ones, so the easy ones, I'll do one of the easy ones. So 8 divided by 0. What happens when you divide by 0? That's kind of weird. Yeah, the answer is it's undefined. It's actually not equal to 0. It's undefined, meaning you can't do it. You can't divide by 0. That might seem very much real. Let me try to be, because math just is representing reality, is all it's doing. Let's think about it for a second. If I put 0 in the top, what if I said, hey, last night I had 0/3 of the pie. Right? So that means that, before I go to the 0 thing, let's just say, what if I had 2/3 of the pie? That'd be a lot of pie. If I ate 2/3 of a pie, so that would mean the pie was cut into 3 pieces. It was cut into 3 pieces, and I ate 2 of them. Right? You know that. I don't need to write that out. You know what that means. I ate 2. The pie took a pie, cut it into 3 pieces, and I ate 2 of them. That's what 2/3 means. So, with that same thought, that's the real life meaning, what does 0/3 mean? If I said, last night I ate 0/3 of the pie. Yeah, that's a weird way to say you ate no pie. Right? That's just 0. But, what if I put the 0 on the bottom? That's not 0, is it? This one is 0. 0 on the top is 0. But what does 0 in the bottom mean? Remember, the bottom number is what you cut it into. Cut it into. How do you cut a pie into 0 pieces? Well, if you don't cut it, it's already 1 piece, isn't it? It's not 0 pieces. It's a whole pie. It's one whole piece. There's no way to cut something into 0 pieces. That's impossible, right? If you don't cut it, it's 1 piece. You can't cut something into 0 pieces. That's impossible. There's no connection between that and the real world. That's not real. That's why we say it's undefined. We mean it has no definition in the real world. It has no connection to reality. So the answer is undefined. So remember, 0 underneath, that helps you remember it. 0 underneath is undefined. 0 on the top is just 0. But 0 underneath is just craziness. It's undefined. You can't do that on that. All right, so they'll try to trick you with that. Watch out for that. Or what that word means. So if I have 8/7, what is reciprocal? Yeah, that means flip it. That means upside down. So all they want you to do is turn it.
So it just says 7/8.
That's it. Yep. So there we go on that. All right. So just give it a flip for all 5 of our tests.
Is it something that it'll be on YouTube so that we can practice and go to the tutor and have them practice with us as well?
Mm-hmm. Yeah, they're actually already out there. The prize. A good question. Let me pause for a second with it. All right, reciprocal of 2. So how do you find the upside down? Reciprocal means upside down. What's upside down of 2? Yep, because this is really 2 over 1, isn't it?
Yeah.
So the upside down is 1 over 2. That's right. Any whole number alone is really over 1, isn't it? So the reciprocal flips it 1/2. Good. All right. Yeah, because 2 is really 2 over 1.
Oh, 2 over 1, okay.
Yeah, any whole number that doesn't look like a fraction, it really is over 1. We'll do that a lot throughout the semester. We'll have a whole number, and we'll say, hey, that's really over 1. If we need to see it as a fraction for some reason, we'll say it's 2 over 1, and then so the upside down is 1 over 2.
So you just put a 1 under the, okay.
Yeah, yep. It's got an invisible understood 1 already there underneath it. Good, okay. So here we have reciprocal of 1 over 9.9. Reciprocal. So what do we do for that one? What's the reciprocal of 1 over 9.9?
9.9.
Yeah, it's just 9.9, isn't it? Because that means over 1. I'm not going to write that. But remember, anything alone is really over an invisible 1. So that 9.9 alone is really over an invisible 1, which means it's really upside down on the original.
So if we put the 1, it's wrong.
Yeah, I don't think they want you to write the 1. Yeah, right. They just say, you're right. Look right there, type of decimal. They just want the 9.9. They don't want the over 1. Yeah, good point. So negative 82 divided by negative 49.
So
Okay.
is that going to be a positive?
Good. So first off, it's going to be a positive, isn't it?
Okay.
But this is a weird one. They're not actually wanting me to figure out the answer. It would be positive if they wanted the answer.
Okay.
What do they want me to do? Well, they say rewrite it. So that's why I said this is a weird question. They don't actually want the answer. They want to rewrite. They don't want me to solve the problem. They want me to rewrite the question, which is strange. So how do they want me to rewrite it? Well, here it is right here. See how what they're wanting? They're wanting the minus 82 to just stay as it is in the front, no change to the front. And then they want me to somehow make it times when it's really not times, it's divide. And then they want to know what comes after the times. They're saying rewrite this division problem as a multiplication problem. Change it. Change it to be, instead of minus 82 divided by something, make it minus 82 times something. Well, how can I do that? How can I change the question?
It also says type as a fraction, so it's basically, what I'm thinking is probably it's going to be 1 over negative 49.
Yeah, exactly. They want you to basically flip it. They're basically keying on the idea, do you know that division is upside down multiplication? That's what they're reminding us of. Do you realize that this is the same as that? That dividing by negative 49 is the same as multiplying by 1 over negative 49. That's the same thing. Dividing is just upside down multiplying, because if you flip it, now it's on the bottom. Now it's divided, isn't it? So that's all they want you to do. They don't want you to do anything more. They don't want you to figure out the answer. All they want you to do is put into this second spot after the negative 82, parentheses, negative 149. That's all they want from you, is a rewrite. Question?
Isn't there another way to do it? For example, using KCF, which is keep change flip, so you would keep the negative.
Did you have Mr. Yang?
Huh?
Keep change. Is that Mr. Yang's?
No, yeah.
Yeah.
Ms. Hester?
Oh, did she say that? Yeah, good, yeah.
So what you do, you would take the 49 over the invisible 1, but you would, but negative 82, this is the part you keep. You change the division to multiplication symbol, and then you flip, which is also the reciprocal, which is 1 over 49.
Very good. Exactly. Yeah, that's a good lingo. I like it. That's another way to say it. Keep, change, flip. That's a good way to say exactly what we're doing. We keep this the same. We change this to times, and you flip this guy. Exactly. I'm saying multiplication is upside down division. Another good way to put it, keep, change, flip. That's right. Keep, change, flip is true because multiplying is upside down dividing. Exactly. So just keep, change, flip. That's exactly what they want. So it's kind of weird. They don't actually want an answer. They just want to rewrite on that one. All right, so that's number 10. Hopefully you made note of it so you're not thrown off when you get to the homework. All right, so they have a minus 6.6 over minus 6.2. And again, rewrite. See over here what they want me to do? They want me to rewrite it as a multiplication problem. So maybe it would help if I wrote it out sideways for you instead of vertical. In other words, it's the same as minus 6.6 divided by minus 6.2. See what I'm saying there? Minus 6.6 over 6.2. That's the same thing as saying divided, isn't it? It's just vertical division, sideways division. Now we can do our keep, change, flip thing. That'll be easy to apply. We just keep this, change the sign in the middle, flip the thing on the right. So keep this the same. Change the sign. What do you change division to? To multiplication. And you flip the 1 on the right, so it'll be 1 over minus 6.2. And that's what they want you to put in the box. So it's a lot like the last one. Is that making sense? It's a little weird, a little out of the ordinary.
That keep, change, flip, though, that's...
A nice succinct way to do that. Yeah. Good. All right, I'll move on. So just write that fraction as a sideways division and then keep, change, flip. Okay, can you do that one? Let me give you a minute on that one. Same kind of thing. I would write it sideways first off. And then keep, change, flip. That good so far? So I've written it sideways because that's what a fraction means. Fraction means division, doesn't it? So there it is, written as division sideways. And now we'll do the keep, change the sign in the middle, flip the 1 on the right. So keep that one the same, change this one to times, and then flip this one. And that's what they want in the box, is that one flipped. What did we do? We just changed division to upside down multiplication. They just are emphasizing for us that division is just upside down multiplication. Good on those strange ones? Questions? Comment? Yeah.
So the negative is down below, but it doesn't matter because the negative
good question.
in front of the 1 or in front of the...
Yeah, really good question. Yeah, let me be clear on that. You're exactly right. It doesn't matter. A negative on a fraction, exactly right. It can go anywhere. So in other words, negative on the top, or negative on the bottom, or even negative in the front, all the same. And Math Excel knows that it'll take it any way. Yeah, really good question. When you have a negative on a fraction, doesn't matter where that negative is. Top, bottom, front, it's all the same thing. It's just a negative fraction, however you do it. Yeah, exactly right. Good. And why? Now, why? I don't want to just be throwing a bunch of math rules at you without reasons. Why? Why are these all the same? Well, remember what we learned earlier? If you just have one negative sign, if you're dividing or multiplying, that's what a fraction is, right? A fraction is dividing two things. If you're dividing or multiplying, two negatives make a positive, but one negative is just negative. So therefore, when I'm dividing these two, and one of them is a negative, whether that's the top one or the bottom one, it doesn't matter. The answer is just negative. Isn't that true? Consistent with the rule? All right. So we have minus a half.
And we can keep doing our same rule, right?
Yeah. So go ahead and do the keep, change, flip thing. That's exactly right. So go ahead. That's a dividing symbol. It's hard to tell. They said the word divide. So that's a dividing symbol in the middle. So go ahead. Now they want an actual answer. They don't want just a rewrite. They want you to go all the way to the end and get an answer now. So go ahead and do that. And you know what to do. Keep, change, flip, and then finish from there. In other words, keep this one the same. change the one in the middle and flip the one out here. So change to times and flip the one on the right. That good so far? Keep, change, flip. So I just changed division to upside down multiplication. Because division and multiplication are the same thing. They're just upside down of each other. Now that we're in multiplication, how do we finish the problem from here?
Straight across.
Yeah, you just go straight. We don't need common denominators, do we? That's only when we're adding, subtracting that we need common denominators. Here we're multiplying, it's not needed. So just go top with top, bottom with bottom. So negative 1 times 3 is negative 3. 2 times 7? 14. Done. Good on that? Questions? All right. If I'm being clear, let me actually slow down on this one. So negative 28.8 divided, that's a divide in the middle there, by 3.2. And they want an answer, right? Simplify your answer. They want an answer. I would just use the calculator. For decimals, I would just hit the buttons on the calculator. So let's see what we get here. I'll do my calculator. 28.8 divided by 3.2. I'm getting negative 9. Just use for decimals, just use your calculator. For fractions, we did them by hand. I mean, the Casio Natural Displays will do the fractions also, if you want. So for decimals, I would just use my calculator. All right. Okay, so they're asking for percent increase, decrease from 95 to 96. So that means we don't need this information at all. That's just like extra unneeded information. They're not even asking us about 1997. They're just saying from 1995 to 1996, looks like enrollment went from 18,000 whatever to 27,000. So it went up quite a bit. They're asking me, what's the percentage of increase? What's the percentage of increase? So whenever you talk about like a part of something, if I said, hey, what part of this class is going to get an A in the end? Maybe there'll be 10 people that get an A in the end of this class. 10 people. But that's not a part, that's just a number. How would I change that to the parts of the class? I'd have to put it over the total. Yeah, I'd have to know about the total, wouldn't I? What is there, about 50 of us? So if I said 10 out of 50 are going to get A's in the end. Now that's a fraction, that's a part. And you can divide it on your calculator and turn it into a percentage. That would be 20%. Your calculator would tell you. So whenever somebody asks us about a percentage, they're asking us about a part of something, which means we need to put on the bottom the total. No, we have to put on the bottom the total. It's the number of people out of the total. So, well, I should say out of the original total. It's always the original. Like if some people dropped later or whatever, 50 would still be the original total. So if enrollment went from 18,779 to 27,642, what's the percent increase? So first off, what is the increase? Let's worry about percentage in a minute. What is the increase? How many more people? We'd have to subtract, wouldn't we? Is that what it is? So just take the 27,642 minus 18,779. And what did you say it is? You got it? 8863? Thank you. 8,863. So that's the increase, but that's not the percentage increase yet. That's just the actual increase. There's 8,863 more students. So now how do we do, like me saying 10 people are going to get A's, but how do we turn that into a percentage? You got to divide by the original total number. So I got to take the 8863 and I've got to divide by the original total. So what's the original total number of people? That's the 18,000. Yeah, 18,000. 0.779. Does that make sense? That's how you do a percent. You got to divide that in a calculator and get a decimal. That's how you do a percentage increase. It's always the number of people over the original total. Because it went up by 8,000 whatever out of 18,000 originally. So that's the part. So take your calculator, take 8863 and divide by 18,779. I'm getting 0.471963 blah, 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 blah. It's plenty there. And now I need to change it to percentage and round it. I'll go through those steps. Everybody good so far? You getting that in your calculator?
So the top number gets divided into the bottom number, and the bottom number gets divided.
Yeah, on your calculator you just simply type this divided by that. So, just from top to bottom. And so now, how do we change? How do you change a decimal to a percentage? Two places, huh? That's why there's 2 zeros in the symbol. So when you put the percentage on there, it's kind of like a magnet. It pulls it 2 places. Like a magnet pulls a little piece of metal. 2 places, so it becomes 47.1963%. Last thing, it says round to the nearest tenth.
So 47.2.
Yeah, the tenths. You guys know where the tenths place is? 10 has 1 zero. So it's 1 place to the right of the decimal. If they said round to the hundredths, that has 2 zeros. That'd be 2 places to the right of the decimal. So tenths place is 1 place to the right decimal. And remember how you round? You look 1 to the right. If it's 5 or more, you go up. So it's 47.2.
How did you scoot those two numbers over?
So the decimal, a percentage means the decimal moves 2 places.
Oh, okay.
That's why there's 2 zeros in the symbol. So the decimal moved 2 places. So I moved the decimal 2 places when I changed it into a percentage, and then I rounded to 47.2. So that's the percent increase on that. Yeah?
Wait, isn't the 4 in the 10th spot? So with round, it would be 0.5?
Well, not after I changed the percentage. So first the order matters here. First change the percentage, and then the 4 is no longer in that spot.
Oh, okay.
And then the 1 is in the 10th place. Yeah, so first move the decimal 2 places. First change the percentage, then do the rounding at the end. Is that good on that? Question? So what I did, so again, I subtracted, they said, what's the increase? So I subtracted and got the number of students increased by 8,863. Put that over the original total. That's always what percentage means, over the original total. Divided on my calculator, got this decimal, moved it 2 places because we had to make it a percentage, and then rounded. 47.19 became 47.2.
So how do you know to round the percentage after it's an actual percentage rather than rounding the decimal?
Rounding first and then? Yeah. Well, because the it's a percentage that they want. They're saying find the percent. So if I said, oh, I'm going to go up here and round this, it's not even a percent yet.
Okay.
You round. When do you round? Like right in the beginning of a problem, or after you have an answer? After you have an answer. Well, I don't even have an answer until I've got the percent, because that's the actual question. Find the percent. So to round right here would be premature because I don't even have the answer yet. I don't have the answer until I've changed it to percentage, which means moved it 2 places.
Because the percentage you have is 47 point whatever.
Yeah, that's the actual percentage. 0.47 is not even a percentage yet. Yeah, good question. So it's not until you have move the decimal that you even have an answer, and then you round. Yeah, rounding is after we have the answer. All right, so that is